So we are going through the Lean Six Sigma overview. This is just a general concepts about what we will study in this course in more detail. So what is the framework for a successful improvement initiative? So what is Lean Six Sigma? You want to improve the process. You want to see how can you make efficiency better, right? And in order to do that, in order to improve your process, you need leadership, creativity, and innovation. So you yourself should have leadership. You will be managing a team. Usually Six Sigma is a team, right? And you have to have leadership skills to motivate your team. You have to be creative. You have to be innovative. So meaning you have to have some idea about if we do work this way, it's better. Why don't we do this? Why don't we do that? You have to be creative, right? You need teaming and employee involvement. You need to have your team who is on your team. They need to, of course, have the skills. They understand how to use all these tools. So not only your team, but the people who are actually working in the process, they need to be involved. You cannot do a process improvement on yourself. You have to get the involvement of everybody in the company also. You will see in many Lean Six Sigma companies, they train everybody. They train everybody about these concepts. Closed loop performance, it's just a cycle. So plan, so you might have read about PDCA cycle, plan, do, check, act. So that is the closed loop performance. You're going to be planning and then doing it and then checking and then action. So that is the closed loop performance. So these all are things which you should have. If you don't have leadership, if you don't have creativity, then you cannot successfully implement the improvement. It's just going to be a research study and then you can't implement it and it's useless, right? So these are the requirements. DMAC. So in Six Sigma, so before we talked about last section about more about lean, we talked about the types of waste, right? And we looked at some examples. We did not see the video. I'm going to show you the video after this about, so remind me, I'll show you the video at the end of the class about lean. Okay, so we'll take a look at that. But I wanted you to understand that lean is one methodology and Six Sigma is another methodology. Okay, so in lean, we have the Mura and the Moody and those, ways that we determine in the process and we improve it. That's the lean methodology. The Six Sigma methodology is this DMAC framework. That is, so it is a methodology where you will define what is the problem, you measure what is the situation of the problem, you analyze the situation, you improve the situation, you do some experiments and improve, and then you control it. Okay, so in between there are toll gate reviews. Each stage will confirm that you have made the right steps. Okay, so what do we do here? And define, we tell what is the goal. So remember we said in Lean Six Sigma mainly three goals. One is to reduce the defects. It could be that you have a lot of quality defects. You want to reduce the number of defects. That could be a goal. Or we are producing 12% of production is defective. We want to reduce it to 7%. That could be a goal. That's one example. Second is reduce cycle time. It takes us 21 days to order raw material, produce, make the product, and then ship it out. We want to reduce the cycle to 11 days. That could be a goal. So you have to define what is the goal. And the third goal is mainly to save cost or money for the company. Maybe you want to save $50,000 for the company. That could be a goal by doing that activity. So you understand the value. What is the value? You have to measure some value, that is some money. You have to see what resources you need and develop a plan. So then you make the project charter. You identify who is the sponsor, who. So sometimes chief executive, if they understand these things, if they're technical, if they're engineering people, or they have understanding about Six Sigma, they will give you, okay, you need to do this, or they'll give you the problem and you have to work on it, and they'll give you resources. Other times you have to create the project. You have to do some research and find these are projects we can work on, and you need to get sponsorship, you need to get money, for hiring, for training, for working on the project, you need to get a sponsor, and you need to establish a team. So that is all in define. You make the plan and think about what we can do. And then in measure, you confirm the goals that what you thought, is that correct? That is your goal. You gather data. Start current right now. Where are we? What is the situation? Somebody said we have 12% defective. Is that true? Maybe it's actually 15. Maybe it's actually 7. You have to confirm by taking some data yourself. Don't rely on other people's data. You have to gather your own data and tell where are we now. In order to make an improvement, you have to know where you are now, right? If you say, I want to save money, I want to save money, you have to know how much money do you have now and how much do you want to have after 1 year. So you need to know where you are now. That is the purpose of measure. In analyze, you determine what is the capability of the process, what is the speed, what are the sources of variation, why is there variation. Defective, sometimes defective is high, sometimes defective is low, sometimes some area has more defects, some area doesn't have defects. There's a variation. Why is that? So you analyze the process. And we will look at some examples how to analyze the process. And then you improve. Then you start thinking, okay, this is why we're getting defective. It could be because of raw material. It could be due to machine. It could be due to people. It could be due to other reasons. You have to then do some experiment. Okay, why don't we make this change? Think about some changes. You plan those changes, conduct some experiments, optimize the process, implement those changes. That is improve phase. And then in control phase, you are going to do mistake proofing. Make sure that your system does not go back to the original problem. Like if you fixed it, if you fix the problem, you don't want it to go back to the original problem. So that is control phase. SOP is standard operating procedures. You'll have standard operating procedures. For example, you have now, once you implement the improved process, you have a written procedure. This is the way we're going to do the work now. You have a written procedure, or maybe you have a video, maybe you have a website with the pictures on it. So all these could be different reasons why you need to develop the SOPs. Okay, so and then implement the solution, identify the other opportunity. Maybe you found that, okay, we did this improvement, but maybe there's other opportunities too. That is in the control phase. So this is the methodology we use in Six Sigma. Okay, and so of course there's at each stage you will think, well, you define a problem. Maybe it's a very small problem. It's only $5,000 saving for the company, and you're going to spend $20,000 on it, and so then you will have a problem. Then then you're going to say it's not a good idea to work on this, right? At each stage you will have to, there's a no decision, and you maintain the focus. You confirm that we're working towards the corporate goals. The toolkit reviews actually are reviews with your top management. When you do the define, you have to discuss with your top management, this is what we're going to do. In measure, you will have a meeting with your top management, and you will tell them, this is what we confirmed, this is the current situation. Then in analyze, you will review with them. We determine what are the reasons for the variation, why we're having this problem. And then here you will discuss with them that we're going to do some experiments. You do the experiments, and then you tell them, yes, good job, we made an improvement. We did what we want to do, or maybe we didn't achieve what we want to do, and we have to try something else. So you will discuss with your top management. So you have to keep them informed about what you're doing in your Six Sigma project. So this, in a summary, is the DMAC framework. Whenever I say DMAC, it's define, measure, analyze, improve, and control. Okay, so any question about this? Is that clear?
No, thank you, teacher. No questions.
Okay, good. So sometimes they say there's an R phase before DMAC. So before you actually start the project, there's recognize. Recognize phase is you are going to so there's a lot of times like I said, you have to first find the problems. In many companies, the Six Sigma team has to find the opportunities, has to recognize. So discovery, there's a lot of different ways you can discover what are the different problems that can arise in the company, and you can find those problems. And that is a realize phase. Sometimes they give you, like if the top management or your senior people, they already understand, they have the data, they can give you, here you go, this is 3, 4, 5 projects you have to work on. But sometimes you have to find it yourself. So then it's called a realize phase also. And then, yeah, so in the recognize phase, it means you can recognize first. You think, okay, is this project, is it a lean Six Sigma project? Do we just need to reduce some waste? Do we just need to look at the muda, the Tim Woods, the inventory? Is it an issue of that? Is it an issue of motion or transport or any of those waiting? What is it? Is that just lean Sigma? Then we just use lean Six Sigma. Or do we need to use Six Sigma, or do we need to use both? So there's where you will do the recognize phase, recognize where the opportunities are, and create an inventory of future projects. You want to have, okay, so if you want to be working in Six Sigma projects, if you work on one project, you started out, and then you finish the project, what happens then? If there's no other opportunity, your career is in trouble. They're going to say, thank you, bye, that's it, your job is finished, right? So you always want to have an inventory of potential projects. Every Six Sigma project has a start date, has an end date. You cannot work on it forever and ever. You have to work on it for, usually it's 2, 3, 4 months project. And it's always good to have 5, 6 projects on the side that you will work on or can work on, and work on 2, 3 at one time. And then when you're completing one, you start another one. So that is very important. So that is also a very important thing. And there's always opportunities. It's not that you can't find opportunities. You should be able to understand how to recognize the opportunities also. So that is also a part of your activity that you have to do. And then in the realize phase, so we said there's RR. So there's a recognize phase at the start, and there's a realize phase at the end. Once you do the control at the end, then there's a realize phase. The project is handed back to the process owners, and the results are tracked. So you are going to give your final improvement. So let's suppose you change the process, and now defects have gone down from 13%, now they're down to 7%. So now you're going to give the process owners, that is the production people, the quality people, the maintenance people, they are going to be given instructions how to do the process so that they keep the defects at a low rate. And usually you track it. You want to track it. You want to make sure your time and effort is not wasted. You will track it for around 1 year, 12 months. You're going to follow through. Are they doing it the way you recommended it or not? Right? So that is the realize phase. So you don't work on the project anymore. You're finished, but you should be monitoring it to make sure that they follow the new process. Okay, so that is a realize phase also. So that is also going to take some time for you every month. So that was just again overview, the define, measure, DMAC. Now we talk a little more detail about each of them. And our next weeks, we're going to talk, of course, in a lot of detail about all these things, but the define phase in more. So first is the D is for define, right? So in define, we said you are going to determine, first of all, you have a large company. There are different areas in it, right? There's different steps in the process. Where is the problem? Is it in one area? Is it in one section? Is it in certain location? Or is it, usually you don't want to take a big project which is for the whole company. You want to work on a problem which is in one area or one step, right? So that is what we need to do. Identify the customers and critical to quality or critical. So you want to work on only critical categories. You don't want to work on something which is just small. It's only not a big deal for the company, right? Because you want to spend your time wisely and compose the problem statement. So you will have to define what is the problem. And our next lecture will talk about problem definition in more detail. Our next lecture is about problem definition also next week. Scope the business problem. What is scope is what is included in your project and what is not. If you're working in an area, you're going to say, I'm going to work on this project and this is only located here and this is only for these equipment and only for this team, and that's it. If there's others, I'm not going to look at that now. Then you map the process. And today we're going to talk about value stream mapping a little bit. That's one way you can map the process. There are other ways also. And identify the measurable characteristics. So you want to control something, you need to be able to measure it. It could be a quality thing. Sometimes you need some fancy equipment, you need some fancy instruments or um, methods to measure it. You need to be able to measure it. There should be some numbers. You need to get some data. You can't just say, oh, this is good, now it's not good. Oh, I see it's nice, now it's not nice. That's not the way. We need some measurable characteristics. So you need to define what are those, right? And so how do we do that? We use different tools. I will show you later on in our measure phase, we're going to use some quantitative tools, which are Pareto diagram, cycle time analysis, SPC, statistical process control, run charts, affinity diagram, tree diagram, fishbone. So these tools, so in Six Sigma, we use a lot of graphs and charts and tables and other types of tools. So these tools are not like screwdriver or like, you know, they're not tools like that. They are your data analysis tools, your presentation tools like charts and graphs. So you decide which ones you will use for that purpose. Determine the process metrics and objective statements. So define the defect and the primary metrics. So usually Six Sigma is focused on a certain defect in your product, right? And so if there's a defect, then you will focus on. So you guys are all mainly electrical background, right? So you're in an electrical program. So if you have a schematic and you're making the PC board for some electrical equipment, maybe there's one part which is always failing. You get a lot of complaints and a lot of problems that this one part is failing, right? For example, in my laptop, two times it happened. My fan in the laptop that failed and it was noisy. It was going car car car, and then I had to Dell and they replaced it. But that is like a defect, right? So there's a defect there. You define the defect in your equipment or in your process, and what is the metric? How do you measure it? Whether it's good or not good. Identify the metrics and estimate the baseline. Baseline means where is it now currently? What is the level for it? That is the reference. Because you want to make improvement. You cannot make improvement if you don't know where you are now, right? So in the define, you have to know what is the current situation, what is the objective. If you have 13% defective, you can't, it's very difficult to make it down to zero, although it should be zero, but maybe you want to bring it down to 5% within the next 2 months. That could be your objective statement. So you need to define that. Identify where will you get the data. Maybe you'll collect it, or maybe there is an equipment already, it's already getting the data and you can get the data from there maybe. So you need to define where you need to get the data from. List the financial metrics. So like we said, you have to do some calculation. What is the dollar value benefit for the company, right? If there's warranty claims, if a lot of people are complaining about this one defect, what is the cost? The cost for the company that, first of all, to order the material, the spare part, and then technician has to go out and change the part. What is the cost? How many times it happens? That's a financial metric you can measure, right? So you need to define current problem, what is the impact for the company, and also people, they are talking about it on social media, and then other people don't want to buy the product because of that problem, right? So that is your financial metric. Baseline forecast is, this is what our standard is, what we want to plan for. Look for extension to other business areas and see. So that is your define the financial impact. And then you want to get to whether team, okay, we're going to work on this problem. You need at least one person who's black belt or green belt certified. So in Six Sigma, we have belts, we have levels. There's white belt, yellow belt, then green belt, and then black belt, just like the karate one. So you identify the process owner, and then you create a project charter. The project charter has these information in it. The project charter will have where is this problem located, what is the problem, why is it important for the company, what is our purpose, what are we going to do, how much money do you need for the project, and how long will this project take, who are the team members, and you need approval from the sponsor for the project charter. And that way then you can launch your, you can start out your project. So this is everything you have to do in define phase. Is that clear? Any question on these? Yes, any question?
No.
Okay, good. So next M, the measure phase. So measure phase, so that was just only planning and just you're getting what you have. Now you actually go and you start gathering information yourself. You want to confirm yourself actual, what is documented and what is actual. And we'll talk about uncovering the hidden factory. That's a part of the value stream mapping. Identify value added and non-value added activities. So in your in your actual process, what is value added and what is non-value added, right? So identify those also, and uh, identify process inputs and outputs. What is coming into the process, what is going out. So you basically are mapping. So as you can see the tools here, you create a cause and effect matrix. We have this problem. What are the reasons? We call it a fishbone diagram or a cause and effect matrix. So you have a whole list of these are the reasons why this is happening. So we'll talk about these later on, the tools, but simply check sheet is just you have a list of problems and yes, it's there, it's not there. Control charts is a graph. Gauge R&R is just to make sure your data is valid. Value analysis, fishbone diagram, process mapping. So these things we do in measure phase. These tools are the ones we use. And you want to understand what are the few main variables you can control. What are the reasons for the problem, right? You get an idea that, okay, we're having this defect because of this reason or these reasons. And you want to make sure your measurement system is proper. If you're using any equipment, you want to make sure your equipment is calibrated properly. People know how to run the equipment. Otherwise, your data will not be valid and your data will have problem. So that is what the gauge R&R is for. There's a methodology to make sure your analyzing system is correct. Otherwise, if your test equipment is not calibrated, your people don't know how to run the equipment, then you will get different results. Determine process capability. So in process capability, you have long-term and short-term capability. Long-term is looking at it overall for like a couple months and years. Short-term is just in 1 month. So we will talk about these like different metrics, CP, process capability, RTY, roll throughput yield. So we'll talk about those. Those of you will at this stage, you want to see currently what is your process, how much defects are happening in your process, what are the problems currently, right? You haven't made any improvement. You're looking at understanding your current process. So that is the main purpose for measure. Okay, and those are the tools you use. In analyze phase, you turn the statistical problem into statistical problem. So, sorry, practical problem into statistical problem. These are tools used. Here now we're starting to use a little bit of statistics. So if you don't like stat, I'm sorry, but you have to do stat in this course. So there's a little bit of statistics. We have to do some data analysis. When I used to go to university, statistics was different. We had to use normal calculator. We had to remember the formulas. I had to look at tables, and you have to do some calculations on your calculator, and then you look up the result on the table, and then you get the answer. Now it's all on computers. Now you have Excel and you have all the statistical data there. You need to just know about the data, which tool to use, which statistical analysis to do, and how to do it, and then what does the result mean. That's it. You don't need to know the formula. You don't need to look at any tables. It's all in the software now. So it's easier, but you have to understand, am I going to use regression analysis, hypothesis testing, mean testing, variance, ANOVA? Which one am I going to use? And we're in this course, we're only going to do 2 or 3 of those. We can't do all of them. It's a long process. And then the FME is the failure mode effects analysis. So those are also the tools. So this is in the analyze phase. Analyze phase, you will do some statistical analysis. You get data from your process, and you will understand your problem. That this problem, what is the reason why it is happening? If I make some changes, what can I make a change? Will it affect it or not? So you start using some data. Okay, so this is the analyze phase. In the improve phase, you're going to implement some of the changes. Okay, to find out what happens system. That is the purpose. You do experiments here in your improve phase. So that is the purpose here. We use design of experiments. So there's a way to actually create the experiments in a proper way. And so those different tools we use in improve phase. And then in C is control phase at the end. So let's suppose you implemented the new solution and good job, you reduced the defects or you reduced the cycle time. Now it's good. Now you have got, you can turn the statistical solution into a practical solution. So you transfer it to the process owner. So once you improve, you are not going to walk away. You have to implement some control measures. Statistical process control, SPC, is, for example, control charts. You will implement some control charts, some data gathering, so that the process stays stable. So that problem does not arise again. Some checks you have to have on it, right? And then you will control and maintain the solution, and you will close the project. Then you will have to make a report and keep the documentation all available. If anyone else wants to see what you did in your project, or you don't remember after 1 year, 2 year, you have the data available. If you do a similar project, you should maintain all the data and information, and keep it available, right? And of course, calculate the benefits. So the company is saving money, and it's not just for 1 year. Usually 5 years, you do calculation that the company will save so much in 5 years, and that is like a benefit for the company, right? So the company, it's an ongoing benefit. If it's a $100,000 benefit over 5 years, we do what is called a net present value calculation, and we calculate the value of it today. So that, in a nutshell, is the explanation of the DMAIC methodology for Six Sigma, and we will discuss about these in more detail in our next classes and in the next course. Any question about this? Okay, and then, so this chart is showing us that in your phases, so in your start, in your measure, analyze, improve, and control phase, these are the different things you will be doing as it goes along down the line. So in this one, you will look at overall under measure. What is you have a lot of different factors under measure. You have all the different factors. You have, you use process mapping, fishbone diagrams, affinity. So this is the number of variables here. The number of variables mean there are a lot of different factors. If you have defects, it could be due to, suppose, 20 different factors. It could be due to gene, due to people, due to raw material, due to a lot of other things, right? So you have a lot of different factors. Then as you are going to go to measure, you narrow down. Okay, this is the top 4 or 5 possible things we can control, and this will reduce the defects. Okay, so you narrow down the possibility to use these tools. Then use quantitative tools and you narrow it down even further. When you implement the change, you can only implement the change in a few of the variables. You cannot control everything, but you will implement some of those changes to some of those variables. And that way, then you will be able to improve the process. And then finally, you do the control. So this is just showing you that at the beginning, you have a lot of factors, and you have to narrow down the factors and focus on the factors which are most important. So I mentioned to you about the levels of expertise in Lean Six Sigma. There's yellow belt, which is just a basic training. A lot of the lower level technician level people in the company, or even the top management, they may be trained just in yellow belt. They know what is lean, they understand what is lean waste, they understand process improvement techniques. This is good. So if they're in the process, they can see and they can understand that, oh, this is a waste, maybe we can improve it. So at least they can observe and they can identify the types of wastes, right? So they are yellow belt. They don't know how to do statistical, or they don't know tools, everything. It's just a basic objective there. Greenbelt is more, you have the understanding of lean and process variation reduction. You have some statistical skills, and you can do different process improvement metrics also. And then black belts, they're fully trained Six Sigma experts. They are like the leading people in a team. So the black belt usually is going to be running the whole project as a project manager, and they are also responsible. They are going to mentor, they're going to train the green belt and the yellow belt people also. And master black belt is more, of course, has lots of years of experience as a black belt, has done a lot of projects, and they are more senior people, and they are the ones who will also train other people also, in addition to helping out anywhere, any project they're stuck, they will be like a consultant, they will guide them. So that is master black belt. And the champion is just somebody who is a senior person, like a senior vice president or top management. They understand Six Sigma and they support it, these projects, and they are going to be helping out in those contexts. So these are different levels of expertise. Yes, any question on this?
Sir,
So
how
some,
to get these belts, sir?
yes,
Like,
good question.
do we need to crack some questions, or like, please can you explain, sir?
Yes, sure. So for certification, yes. So once you do this course, you will probably be able to do green or yellow belt certification. Okay, so black belt is more complex. You need to have a lot of statistical background. So you may be able to do these. So I will, so towards the end, I will give you guidance about there are different websites you can go to, and you can take the exam and you can get a certification. Okay, so the most common one is ASQ, American Society of Quality. But for green belt, you need to have experience there to take the green belt exam. So you will probably be able to do only the yellow belt. But there are other websites, you don't need experience, you can get a green belt also. So that is your starting point. So there are different websites. You will get the course material, you will get also the exams, and you can get yourself certified through there. So I will guide you towards the end of the course for that. After the mid, I will give you information on that. Okay,
Thank you, sir.
sure. So nothing is perfect. Sometimes it happens that Six Sigma projects are just a waste of time. Sometimes they will not result in benefit for the company. Why? These are the reasons why. They may not be relevant to customers or to business needs. Maybe you didn't do a proper analysis of what is the benefit for the company. It's more like, oh, we will just be able to do work faster or better, but you didn't measure the benefit. Project scope is too large. Like I said, if you are going to do a project for the whole company, or that's very difficult. That's not what you should do. The scope is too large. You should do it on one area or one, section of, or one problem. If it's a large project, you should break it down into different smaller projects. Relevant data is hard to collect, or there's too much data. Either you have a lot of data and you don't know which one to use, or you don't have any data and it's hard to get the data. Maybe the factory that you have to work on is far away and you cannot go there and observe. So then that is a problem. Can't define what a defect is. So your defective has to be defined properly. Process doesn't cycle in often enough. Maybe it takes a long time for the whole process to go. It maybe takes 2-3 weeks for the whole process. So it could be very long. You have to wait and make changes. Problem is written in the solution. If you already know the solution, you don't need to do this project. If you know this problem is because we have our raw material from this supplier is faulty, other ones are okay. You know the solution. You know the solution. You have to talk to that supplier and either tell them we need better quality, or penalize them, or go help them improve the quality, implement the solution. You don't need to do a whole project to find out what can we do, blah blah blah. This is Six Sigma is done when you don't have a solution. If you have a solution, then just implement it. It's a just do it. Okay, so that is also why if you do the whole project in a fancy 2 3 months and you know the solution already, it's just a waste of time. Recent changes in the process, you're working on the process, and then suddenly there's new equipment or new process comes in, and so then your work is useless. So that is also not good. No support from business leadership. So if you're working on a project and you don't have support, you don't have commitment from the top man, they say, ah, just forget it, it's just a waste of time, it's okay, just do production. Some companies are only focused on production. They just want to produce, they don't care about quality or process improvement or efficiency. Then your effort is useless, then you're just wasting your time, right? And company culture, yes, if you find out how to improve the process and the people in the company, they don't agree, they're like, they work there 20 years 15 years, they say, oh, we always been doing it this way, we don't need to make this change, it doesn't make a big difference, they don't agree to you, then you're having trouble again, because the company culture will not allow for the change. So even if you determine what can be improved, if you cannot implement it, then there's a problem also there, then your work is useless. So these are all reasons why Six Sigma may fail, may not be a good process, may not be a good project to work on. So more on recognize phase. Recognize phase is basically, this was at the beginning, remember we said, um, you will have a list of different projects, usually 5 6 10, you always want to have some projects to work on, right? You need to calculate the benefit for all of them. There may be some which have a high benefit for the company, you could save a lot of money for the company, others middle, other maybe low benefit there. And then effort, how much effort do you need to do to work on the project? If it is low effort and the benefit is not very high, these are more like not desirable. These ones are more quick hit. Maybe there's a small benefit, small effort, maybe just get 2 3 people to work on it 1 2 weeks and get it over with. Those are just like, small mini projects, you could say, right? You don't need to do a full demac process on that, right? Now, these here, those which have a high benefit and low effort, they are highly desirable opportunity. Those are the ones where you should focus on, right? And then these are ones where there is a little bit medium benefit and medium effort. You can, these are desirable also. You need to do more analysis here. These ones, if you have very high effort, but the benefit is very low, you don't want to do this either. This is least desirable, right? So you need to define for each of your potential projects, what is the benefit for it, how much effort is involved, and is it a strategic fit? Is there, what are the benefits? Is it just a customer satisfaction? Is it just our customer will be happier, they'll buy more from us? Is it just that? Or is it revenue growth? Are we going to sell more product and get more revenue? Or are we going to reduce the quality cost? As you probably know, quality has a lot of costs involved with it. There's warranty cost, there's also inspection cost, there's appraisal cost, there's your cost for so many other costs. So can you reduce that cost? So you need to define that. That is what we mean by benefits. So when we're talking about benefits here, this is what we mean. You need to define the benefit in one of these aspects for the project. When we're talking about effort, we're talking about people, resources. How much resources do you need? Do you need special equipment? What is the time frame? If you need a lot of time for it, then that also is a large time frame. What is the capital cost in order to do the project? How much money do you need also? And what is the risk of the opportunity? So these are your effort aspects here. So based on that, you will know how to focus, which projects should you focus on. Here, any question on this? So top down, bottom up. Yeah. So top down, bottom up. So top down, we look at strategy analysis, financial analysis, voice of customer, process analysis. So we look at the overall strategy for the company, the overall financial, and so you do need to know some financial analysis. In order to be a Six Sigma person, part of it is cost benefit analysis. So you need to be able to do that. Voice of the customer is, you need to understand what is important for the customer. The customer may think something else is important and you're working on something else. So you need to know what is the voice of the customer. And then process analysis, you need to know how to actually undertake your process analysis also, right? And then bottom up is looking at senior management. You need to also describe the pain that you feel. So senior management would be also describing the pain, and broader organization and tactical analysis. Yes, Navdeep, you have a question?
Sir, my question is how can we remember such all the data and all the things it for examination point of view?
Remember, you mean what I described so far?
Um, yes, a kind of like all the data we have to remember, and when the exam will come, we have to write it on paper.
So I guess, I mean, you will remember once you do it. So right now it's just theory. See, now when we do use the actual tools, for example, we're going to talk about value stream mapping today. When you do it yourself, then you will remember. Okay, if you just read, you will not remember it. That's right. So I will give you the assignments, you'll work on it in the groups. That way you will understand it and then you will remember these things. So, and so part of your examination, as you know, are assignments. If you work on assignments, you demonstrate you understand the concepts. And then secondly, in the quizzes, there are multiple choice questions and there's also written question. So if you understand what I'm explaining, then you should be able to answer the questions and you will get a good mark. But it's not just only the mark, it's also the skills. You should be able to do the data analysis yourself also, that we will be talking about. Does that answer your question?
Yes, sir. Thank you, sir.
Yes, thank you. Yeah, no, we will do it practically, then it will be easier. Yes. So one way of understanding the process first is to do a value stream map. So there are different ways of doing mapping. There's process mapping, there's value stream mapping, there's other types of maps also. We're going to look at the value stream map. Okay, so let's take a look. Before we do that though, okay, before we go to value stream map, I want to go back a little bit to the other one, the yeah, Six Sigma. I think Belda just explained. Yes, we will. Yeah, okay. Vamsi also asked after 6 months if new problem arise due to process change for improving efficiency, which result in reduction of production again, then who will be responsible, right? So yeah, it's usually, like we said, 1 year, the Six Sigma team is responsible to monitor. Usually if something happens again, problem again arises, then you have to go back and you have to again go and you have to look at the problem and you have to check and see what is the reason, and then you may have to do your improvement again process. So yeah, Six Sigma team will be responsible because the production people don't know what you did and you have to go back and do that. Okay, and so I just already mentioned about how to get the Six Sigma also. So that also I did. Okay. So, so in that context, so next I'm going to show you a video actually of lean. So let me just bring that up and I will put this also. This is a good, so we talked about lean last time and I want you to see what is, how lean is implemented in a company. What is lean? You want to reduce waste, you want to reduce all those problems in the company, right? This is 13 minutes long, but I'm going to just show you a part of it. The important parts, I'm going to move it up a little bit. Let me share my screen and we can take a look at that. Okay, so let me just bring that up. Let me share screen. So guys, please watch this, very interesting. So this company is in US. Let me share here. Okay. So this company, I'm going to stop my video so you can see it clearly. Yeah, so this company is in US in Washington State, and it produces labels, labels of stickers for different companies. So he's going to take you around the company, the factory, and show you lean, how they implemented lean. Okay, so let's watch this and I'll stop it and we'll have a discussion about it. So make down notes. What you saw is interesting. At the end, I'm going to ask you guys, let's have a discussion about what you find interesting in this video. What are the lean, different types of um, uh, tools and things they did that is saving the lean issues.
Time to take a tour of FastCap. FastCap is located in Bellingham, Washington, just about 2 hours north of Seattle, up in a little tiny town called Ferndale, right on I-5. It's a beautiful place. We have about a 50,000 square foot facility. It's just really, really cool place to work. About 110 windows, lots of natural light everywhere coming in. We're going to take you inside. Now remember, it's simple. It's not fancy. So when you get inside, just a big overview. We got 3 big-ass fans keeping everything cool and lots of natural light everywhere. When you walk in the front door, it's all...
Sorry, let me add the captions also. I didn't ask. Okay, here's a caption, so you should be able to understand. You guys can hear also, right? And you can listen. Sound is coming.
We got 3 big-ass fans keeping everything cool and lots of natural light everywhere. When you walk in the front door, it's all stand-up. We made all the desks out of our fast pipe system. Everything's simple. Now, people always say, well, do people like to stand up? We wouldn't have it any other way. Is it difficult to stand up? Sure, it takes a little time to get used to it, but we love it. Everything's on wheels. Everything's flexible, including the...
So they're all their cabinets. Everything is on wheels. They can move things around easily. It's not like they're stuck in that. They can always, it's flexible, right? So that is a saving. If you need more equipment or you need to move it around, it's very easy. So that's one thing that helps.
The filing cabinets. Now this is looking from the office back into the shipping area, and from the shipping area back in towards the office. You notice there's no walls. This is our order desk, and it's all on wheels, and it's all color-coded based on the day of the week.
So see, each of them, they have Monday, Tuesday, one different color. So you know this is blue, so this is something which has to be shipped out on Friday. So just by looking at the color coding, you know when to ship it out.
So whatever day of the week is, the invoices are that color, so we can quickly tell whether or not we're behind or ahead, whether or not we have flow. When you look up on the wall, all the boxes that we ship in are all color-coded. So it's easy to identify what size box is the perfect size to ship in, and then when you need to find it, it's color-coded down below as well. All LED lights, all radiant heat. It's just an incredible place to work. So this is our grocery aisle, and right here is our shipping terminal. So 90% of all of our finished products are right here. We build the Kanbans every day, and everything's clearly done through visual controls.
So as you can see here, and so probably Amazon also uses the same situation. All the warehouses you go to, here they have exactly what it is, right, in big letters. They know what size it is, the label. There's a picture also of the product inside, right? It's not like we don't know what's inside it, right? And the code number is there for them, and it's here also, so they know that this is at the right place, right? So it's easy to find this here.
And the last 5 digits of the UPC code. So if you want to know what's there, there's a picture of it right here. And all these labels have been made by us. And it just allows us to manage our daily picking. As you can see, Thomas is down here picking an order right now on a cart that we made. And it's just very simple. This one main aisle all the way down to the shipping terminal, and it's out the door. Our showroom, our conference room, very simple, stand up, no chairs. The meetings don't last very long. Our graphic design area, again, everything's stand up, everything's on wheels, everything's flexible. We want to be flexible because our needs are always changing. All our tools.
So for tools, you know, you might have seen in factory, if you go work in a factory, all the tools disappear, you don't know where they are. And so they have, this is, you know, foam cutout, they cut out in the foam for the tools, and they are all placed at the right place. So if there's missing tool at the end of the shift, you have to find it and you have to fill it. You make sure you put it back. So this way you can't lose the tool, so you don't waste time looking for the tools.
Are carefully shadowed. We never search for anything. We never struggle, because the minute you struggle, you have waste.
Hi, I'm Graham, and welcome to Graphics. This is the most magical cell in the whole building. We produce all our labels and inserts for over 700 products right here in this tiny cell that's this big. Back here, we've got all our paper racks of the different labels we use. Over here, we've got our computer where we developed a 6-step process where anyone can come off the street, follow the very basic steps, and get the job done in 2 to 3 minutes. And then over here, if ever anybody runs out of paper, we've developed a very simple Kanban card system where anyone can understand exactly what they need to do for any the process. All right.
So what is a Kanban? So we heard Kanban a few times. It's basically, we mentioned it's a signal. It's like that. See, there's 3 reams here. They have a card. If you're running low on paper, you will reorder that paper using that card, that's a signal. So you never run out of paper. It's not like you're working and then there's no paper and you can't do the work, right? So there's a signal that now you're below and you need to order more paper. So that is a Kanban.
All right, so at the end of the day, we've got a great process that allows anyone to come in on their first day and run a $150,000 printer for a giant company producing all the labels and inserts just out of the first day.
Our bathrooms are beautiful. Fresh flowers, granite countertops, polished concrete floors, bidet toilet seats. I mean, it's really a great place to work because we want work to be fun and enjoyable. We keep it sparkling clean every day. Callie cleans the floors with automatic floor cleaners. We have 2 of them, and everything just stays at a very...
So part of lean is also that you need to have clean everything, and everything should be accessible, and there's easy flow of equipment, flow of people, and as you can see, cleanliness is also part of it, and the floors are smooth. It's not like you can't take something somewhere else, right? So it's all flexible and clean.
High standard. This is our sandbox where we meet every morning for our morning meeting, and a new person leads it every day. Our kitchen open to the entire facility, no wall. We even have a lean dishwasher. It does a load in just 2 minutes, no batch work. Our main production line, everything flowing towards the shipping terminals. You'll see how that works here in just a minute. It's very cool. See, that's an aisle where the product is made, flows down to the area where we package it. People are in the cells, they pick, package, and ship. Everything 2 hours, fax to truck. It's pretty amazing. So this is another cell where we make the laser jam, and Austin is laying out a tape measure on an aluminum pole to make the laser leveling device. And this is a nice little cell that he works around and makes one product at a time. Again, all of his tools are carefully shadowed in Kaizen foam. No struggle. Work should be easy. He goes from one cell to another cell. Notice where he grabbed his safety glasses directly above the saw, goes ahead, makes a cut. And now what's really cool about this, you're going to see, is Austin's going to have to clean out the aluminum pipe. He goes, sticks in a vacuum, hits it with a foot pedal. It sucks the aluminum dust right out. It's so fast and so easy. This is an engineering cell and also where we make the best fence, and those are the engineers standing up in the production area. We do all of our 3D modeling, and then we go ahead and do stereolithography.
Okay, so this is our engineering team. They both have their own scooters. Doug's version. Okay, so what happens, Doug? Let off your foot. So now you can let go of it.
As soon as I put my weight on, then this little pad lifts up.
Okay, so there you go. Now it stands up. Now look at JT, another engineer, has another design. His is the kickstand mode. That's how we think here at FastCap. You guys are crazy.
Pretty awesome. This is our shadow board of all the products that we make. So we do lateral thinking. We walk up, we look at it and say, hey, we've made a part like that before. We've got scooters here that allow us to get around the entire facility. Again, this is the engineering cell right on the manufacturing floor where we make everything. Our wood shop.
So they're talking about cells. So see, okay, think of it, we're going to do value stream mapping. So in the value stream mapping, you have different workstations, right? So you saw that there's a cell for printing, there's a cell for packaging, there's a cell for shipping, so all those different cells, they work together if and everything is flowing through, right?
Here at FastCap. You guys are crazy.
Pretty awesome. This is our shadow board of all the products that we make. So we do lateral thinking. We walk up, we look at it and say, hey, we've made a part like that before. We've got scooters here that allow us to get around the entire facility. Again, this is the engineering cell right on the manufacturing floor where we make everything. Our wood shop is only missing one thing, sawdust. It's immaculate. All the tools are carefully laid out and organized so we can be highly productive. Again, we're not about struggling. We're about making work easy and fun. Everything's where it's supposed to be. Everybody enjoys work because work doesn't have to be a struggle. This is our Cnc area where we make all of our molds. All of our toolboxes are carefully shadowed out with our Kaizen foam system So when we go to get a tool, it's right where we want it. There's no surprises like, oh, what happened to that tool? I know that's somewhere. We're not spending hours a day looking for things. We know exactly where everything is. So again, work is enjoyable. It makes all the difference in the world when you take the time to make this happen. Now, the way this looks like this is every day we make an improvement. These are our injection molding machines. They're Sumitomos. They're really high tech. They're very cool. They have robots on them to remove parts. All the tools, again, are shadowed out for the Sumitomos. These are all of our injection molds down below with the parts actually magnetically attached to them. These are all the colorants and materials that we use with Kanban cards, carefully inserted in. All the parts are glued on the front. And then this is our narrow.
Okay, so I'm going to put that there, but you can watch it. I mean,
a great system, allows for a lot of
flexibility.
Everything gets maintained, battery gets charged.
Look at
throw a bunch of it out. But yes, FastCap has junk.
So also
at the very end,
there's always a waste. So they have a place where they put all the junk in, and of course they're throwing it out regularly, right?
We have all the stuff
in the factory
that we take out of and sort out of our office. So there's mine right there, Paul's desk junk. So anything we don't need, we get it out of here, and then we'll sort through this every 3 or 4 months, and we'll throw a bunch of it out. But yes, FastCap has junk. It's called Nudge, and we get rid of it out of our work area so that we always work in a perfect area that's clean and organized.
So we even do lean in our aircraft. We have a corporate plane, and I fly that.
So I just shut down my plane, and this whole facility on razors, because it allows us to overcome the size of this place because it's 50,000 square feet. It is absolutely huge. And I'm going to do one last thing to end this tour, just for fun. I'm going to run up the stairs so you can see what it's like up above, so you can see how beautiful this facility is.
So there you have it, a
it is
lean
cool.
tour of FastCap. The reason I did this is I get 2 or 3 tour requests every day, and I just couldn't keep up with the demand. I thought, how can I make this process lean? So I made a video to kind of show people. Now you can watch it with your team, you can pause it, you can talk about it, it's all there. And the way we accomplish all this is so simple.
Okay, so yes, how was that? What do you guys think? Was that interesting? Did you get some good ideas about lean? Yes.
Very
Yes, sir.
interesting. Very interesting.
It was very helpful.
So what was interesting? Anybody want to tell what they thought was interesting, was useful, which saves time, effort? What is this reducing the waste?
Shattering their tools.
Sorry?
Shattering their tools.
Okay. Yes. What else? Anybody else?
Everything is movable.
The moving
Flexible,
more
you can
furniture.
move things around. The
Using
floor is
labels.
Color codes.
color coding,
Yeah.
labeling
Using
of everything.
Energy savings by not using lights but natural lights.
Using
Natural light.
Kaizen too.
Yes. Right.
Not keeping the
everything.
junks with them.
Yeah, not keeping junk. There's no junk all over in the factory. It's only at one place, and then they throw it out, right? Yes. What else?
Scooter to get around.
They have even labelized them.
Yes, scooter to run around. So it saves time again. See the motion. So if you have people, it's a 50,000 square foot place. If you need to go from one place to the other, it will take you some time to get there, right? So this way quickly you can just go through and the floor is smooth and it's clean. There's no issue with the flooring. And so you can get there quickly. So that saves time also. It makes a difference in the process, right?
Yes.
Shattering their previously manufactured products so that if any new product comes, maybe it may be similar to that, it will reduce their work.
Yes, that's right. And similarly, you saw in the printing, like they have, it's the main job they have to make different things. One is the labeling, printing labels. So that big machine, the printing machine, there's a visual factory, we call it. They have like pictures, how to do first, second, third step, press this button and pictures of it, and where to get the paper, everything. So all that is organized. It's not if you come there, you don't know what to do. You have to ask somebody, where's the person? What do I do next? It's all clear there, right? That reduces waste also. Then they don't waste it. So if they don't know what they're doing, they're going to put paper in and print out and it's waste and then throw it away. And that's the waste of time, waste of money, right?
Teacher, in the video,
Yes.
they told something about Pokayoke. In the video, I'm not sure, but I heard
Yes.
about something like that. Poka-yoke.
Yes, poker yoke is mistake proofing. So there, for example, before you send it out, you check and make sure that it's the right order. Or you have, for example, a box, and you only put the right size in that box item. So that is mistake proofing to make sure things don't go wrong.
Yeah.
That is, for example, in our car, we have, the gas, the gas needle. When it goes down low, then the light comes on that you are low in gas. That's a poker yoke. It's an indicator that something can go wrong. Right?
Like in electrician, when we have a socket, a plug socket, and we need to use the right socket in our mobile, in a power source, for example, we need
Yes,
to confirm that the plug is the correct for the power supply.
that's right. Yes, exactly. Yes, yes. Good. Okay, so that's good. So yes, anybody else? Yeah. What
Yes,
else?
yes, I have a question. Or I don't know if it's a, maybe this is a question. When you working with machines, I understand you should stay in standing all time. I understand that. But when you have other kind of job, maybe with your computer or maybe finance things, maybe you need to stay in your seat. I don't understand because in this place all time are standing all time. I think maybe these things they should preview because all time 8 hours maybe it's too time without a seat.
So is your question about how it is implemented in like computerized environment and in like software? Is that your question?
Not teacher. I talking about the comfortable time maybe because all time you are standing maybe it's too tired for the workers that without working with machines. With the all time are in your computer, maybe you need to take a seat with your maybe I think.
Yes. Yeah, the time they spend on the machine also is important. Yes. So there, remember we talked about leveling also. They want to make sure everybody has work to do. Nobody's waiting idle, right? So we will talk about that in more detail in our value stream mapping. Yes, exactly. Yes, that's right. Yes. So flow of
Sir,
material.
he is talking about the seats. I mean, nobody is allowed to sit,
Yes.
right?
Yes.
He's talking about that.
Yeah, you have to stand. Yes, that's also that helps to keep people active, right? So if like you're sitting, then you're more relaxed, and then you can't walk around. If you want to talk to your neighbor, you have to get up and go. Here it's easy. You can just move around and talk to them, and it's flexible. Yes, and even the meetings, you see, even the meetings, they're stand up. So it's not like you spend the whole day in the meeting. It's just 5-10 minutes. Go stand up, talk what you need to, and go back to work. So that reduces waste also. Yes. So standing up, that they find that that reduces the time wasted. Yes, right. Good. Okay, guys. So it's 9:12. So we do have, our class is actually 4 hours, but technically we need to also do like a lab. Lab is more in terms of the practical work. Like if it was the real world, I would be giving you assignment and I can walk around, but that's not. We can't do that. So what we're going to do is we're going to take a 5-minute break, and then we're going to come back, and I'm going to go through value stream mapping exercise with you guys to make you understand about value stream mapping. We're going to talk about design for Six Sigma, and so I'm going to give you your homework. You need to do some study for value stream mapping. Then next week when we come in, next week, there's going to be some course content I have to cover for the next week. But there also will be your assignment will be due for at the end of the next week. So at the next, sorry, in the end of the class. So next week when you come, so uh, on June the 3rd is our next class. On that day, we will have first 1 hour course content discussion, and then I will give you time to work on your value stream map assignment, and you will work in groups. It is a group assignment. So you might have seen there are 8 groups that I made for you guys randomly. So you will work in your groups. You will have Zoom meetings. So I will put you in, so one person I will assign in each group as the leader who will set up the Zoom meeting. and you will create a Zoom meeting, and you will have a meeting with your group, 8 people, and you will work on the assignment. And you need to submit the assignment by the end of the class. You have to work in the class. If you have any questions, I will be there to help you. But that is the purpose for next week also. And then it needs to be submitted by the end of the class. So let's take a 5-minute break, and then we will come back and we will then continue. And then we will be able to have the rest of the discussion today. And so we should be done in about 45 minutes more. By 10 a.m. we should be finished. Okay, so I'll see you guys in 5 minutes. Okay.
Sir,
Yes.
I missed the attendance due to connectivity issue.
Sorry, who is this?
Sir, this is Naufal. Sir, I missed the attendance due to connectivity issue.
Okay, so I'm gonna put you as late. That's fine, but late is getting 50%. So please, you need to make sure your connectivity is all perfect, because all of your classes will be affected by it. So try to get the best connection you can get. Okay, I will mark you Naufal.
Okay.
All right, thank you.
Thank you, sir.
Okay, see you guys 5 minutes.
Thank you, sir.